All right, everybody. So today we're going to be talking about three-step stoichiometry. All right. And the first step with three-step stoichiometry is kind of mapping out a strategy. And I'm going to give you an example. But first thing, here's what some things you already know. You already know how to go from grams of something into moles of something. Use molar mass. We've practiced that. You also know how to go of moles of one thing to moles of another thing. That's using balanced equation. And both of these are using dimensional analysis. But let's look at this example problem. In this example problem, it says oxygen gas mixes with hydrogen gas to form liquid water. So it first tells you what the reaction is. And then it says, if you start with 36 grams of oxygen gas, how many grams of water will you make? Okay. So the thing is, there's no single conversion between grams of one thing to grams to another thing. You have to do a series of conversions. All right. And it looks something like this. You have to go from the mass of the first thing into the moles, and then moles to moles, and then moles back out to mass. So let's go ahead and write that into our interactive notebook right here. We have mass of the first thing. In this case, it's oxygen. So we go from the mass of oxygen to the moles of oxygen. I'm just putting A because it's just a sample. And then we can get it to whatever we want. In this case, it's water, moles of B, and then mass of B. Okay. And this is the strategy. I call this mapping it out. This is called stoichiometry island. So we start with right here, mass of oxygen. We go to moles of oxygen, moles of water, to grams of water. Okay, so it's a three-step problem. All right. And the thing is, we know how to do that. Right here, we use the molar mass, okay, to go from here to here. On this one right here, it's the balanced equation. And here we use molar mass. This one is molar mass of B. This is molar mass of A. Okay, cool, cool. All right, so now it's time to do the problem, okay? And the first thing that I recommend is starting with the balanced equation, okay? So in this balanced equation, sometimes I'll give it to you. In this case, I just say there's hydrogen gas combining with oxygen gas to form liquid water, and we have to balance it. So over on this side, I say I have two oxygens. That means on this side, I have to have two oxygens. That means on this side, I have four hydrogens. That means I have four hydrogens. And then on this side, I have one oxygen gas. So the first step right here is write the balanced equation. I have it written. Bam. The next thing I'm going to do is, just like before, I am going to write down what I have and what I want. So in this case right here, I have 36 grams of O2. And you don't need to write the word of, and you don't even need to write the word grams. You just kind of write it like that, 36 grams of O2. And that's going to give me blank amount or grams of H2O. Okay, so I always kind of analyze what I start off with, what the problem gives me, 36 grams of oxygen gas, and what I want, grams of water, grams of water. And now this right here, this is the new part. This is the step that's kind of new. Okay, well, not this first part. This first part is just writing down what you have, 36 grams O2. And what you want is grams of H2O. Okay, this is the new part, is basically getting it so we can go from grams of O2 to grams of H2O, and it's a three-step. So we have to go from mass to moles, moles to moles, moles to B. These ones right here kind of fit in there. So first thing is, I'm going to go from grams of oxygen to moles of oxygen gas, okay? And I do not worry about the numbers at the beginning. Then once I have moles of oxygen gas, I can go from moles of oxygen to moles of H2O, okay? Once I have moles of water, I can go to grams of water, like that. So remember, whatever I start off with, it goes in the it goes down below on the next one. So for instance, I have on this one right here, grams of O2. That's going to go to grams of O2. I'm in this first one, I get to moles of O2, moles of H2O. So you always, whatever's in the previous column up above always goes to the next one. Cool, cool. So right now, everything perfectly lines up. So grams of O2 matches grams of O2, moles of O2, moles of O2, moles of H2O, moles of H2O, and I'm left with grams of H2O. Cool, cool. So the next step is determining what I put in these values, okay? And to do these, I have to have do a little bit of the side hustle. I have to figure out what my molar masses are. I have to figure out what my molar mass of oxygen is, and I have to figure out my molar mass of water. And that's what these squares down here are for. So with oxygen gas, there's two, because there's a two right here, two of every oxygen, and each one, I can look at my periodic table. How much does oxygen weigh? Oh, oxygen weighs 15.999, 15.999. So 2 times 15.999 is 31.998, and that's how much the molar mass of oxygen gas is. Okay, same thing over here. In H2O, there are 2 hydrogens and 1 oxygen. We know we just did oxygen is 15.999, and hydrogen is 1.008. That means 2 times 1.008 is 1.016. And that should be a 2 out in front. And this right here is 15.999. And then the last step is I just need to add those together. So I say 2.016 plus 15.999. Oops, I made a mistake. 2.016 plus 15.999 equals 18.015, 18.015 grams per mole. All right, now we're ready to put these numbers in. All right, so now that we have this all ready to go, we can start to input some numbers. So let's look over here. The molar mass of O2 is 31.998 grams per mole. So the number is always associated with the grams. It'll always be next to the grams. So in this case, it's going to be on the bottom, 31.998 grams for every 1 mole. This is grams per mole, or in other words, grams per 1 mole. Let's look at this one over here. It's 18.015 grams per 1 mole. But in this case, it's on top because the grams is on top. So I have 18.015 grams for every 1 mole. The last numbers that we need to input are these ones right here, the mole to mole ratio. So I have moles and moles, and to do that, I use the balanced equation. So I have moles of water, and I look at the number that comes out in front, and there's a 2. So there's a 2 that comes before water, and I look at oxygen gas, and it's a 1. I have 1 right here. Cool, cool. All right, so the last step is the math step. And basically what I'm going to do is I'm going to multiply everything on top. So 36 times 1 times 2 times 18.5. And I'm going to do that first, okay? And when I do that, I need to press enter at the end. So watch how I use the calculator here. I'm going to go like this. I'm going to say 36 times 1 times 2 times 18.015, enter. You have to press the enter button at the end of it, okay? Then I'm going to divide it by everything on the bottom individually. Divided by, in this case, 31.998, and then divided by 1, divided by 1, divided by 1, and divided by 1 equals 40.53. Okay, and that right there is my final answer. And technically speaking, this only has 2 significant figures, so I'd round this to 2, so I get 41 grams of water.